everybody. Sorry I can't be here today. I'm going to go through a quick lesson on function operations. We're going to focus primarily on linear equations since I'm not here and I don't want you guys to get stuck. And I just essentially want to show you how you can perform your various arithmetic operations, addition, subtraction, multiplication, and division on a function. I also want to show you how to evaluate functions and how to, there's also another operation called composition of functions. So I'm going to show you some basic strategies that you can do without me here. So we're going to start with function operations. So if you have two functions, let's just call them f of x and g of x, you can actually add them, you can subtract them, multiply and divide them, just like you can with numbers. The notation is provided for you. So for example, if I decide to call some new function h of x, and I develop h of x by simply adding my function f to my function g, and notice that there's two ways that we can write it. I can write it as f of x plus g of x, or I can just say it's the same as f of x, or I'm sorry, f of plus g of x. They mean the same thing. I'm just adding the two functions together. So if I have an example here where f of x is 2x and g of x is x plus 1, all I'm doing is adding my function f of x, which is 2x, to my function g of x, which is x plus 1. Now with addition, we don't have to worry about grouping symbols. I can simply just combine my like terms, and so that's going to give me 3x plus 1. With subtraction, though, we have to be a little bit more careful. So if I subtract f of x minus g of x, I've got to remember that I'm subtracting all of g of x. So with subtraction, you will need to remember your grouping symbols because I'm subtracting the entire quantity x plus 1. And so if I'm subtracting the entire quantity, I've got to remember that I'm subtracting the x and I'm subtracting the 1. So this expression becomes 2x minus x, but I've also got to distribute the negative to the 1. And so 2x minus x, when I combine my x's, just leaves me with 1x, and then I've got my minus 1 as well. Multiplication. So if I want to multiply f of x times g of x, again, this is where I'm going to need some grouping symbols. So I'm going to take 2x, but I want to multiply it times the quantity x plus 1. And you do need to remember that when you're multiplying, you do need to distribute. So I'm multiplying 2x times x, and since x times x is x squared, that's going to leave me with 2x squared. But I also have to distribute the 2x to the 1, and so that's going to leave me with a plus 2x. There's really nothing I can do to simplify this because I cannot add an x squared to an x. So it's just simply 2x squared plus 2x. Division at this point, there's really not going to be much you can do. Once we get into quadratics and factoring, we'll talk about how to simplify. But at this point, if I'm dividing f of x by g of x, it's simply going to be 2x over x plus 1. If it is something that you can simplify, great. So for example, if f of x was, for example, 4 and g of x was, I don't know, 8x, and I wanted to do, let me just get this out of the way. There we go. So if I wanted to divide these, f of x, let's do it this way. This would be f divided by g of x. Then I'm just taking 4 over 8x. And I can simplify here because 4 over 8 is simply 1/2. So that would actually just reduce to 1 over 2x. But as soon as we have an expression that involves addition or subtraction, simplifying our fraction becomes a little bit more complicated, and we'll talk about that later on in the course. All right. So here's an example, and what I'd like you to do is take a second to simplify or to evaluate each of these functions or to perform the operations. If you could please pause the video and work on these on your own and then start it back up, that would be great. Okay, so in part A, you're asked to add f of x plus g of x. And again, with addition, you don't need to worry about grouping symbols. So if my function f of x is just x plus 2, and I want to add that to my function g of x, let me actually use a different color. My function g of x is 4x minus 1. Then all I need to do now is add my like terms. So I've got a positive x here and a positive 4x here. When I add them together, I get 5x. And then when I combine my positive 2 with my negative 1, that's going to leave me with a positive 1. Remember, with subtraction, you do need to use the grouping symbols. So it starts off with my function f of x, which is x plus 2, and then I want to subtract the function g of x, but I have to put that in parentheses, so it's going to be 4x minus 1. And then you have to remember, if I'm subtracting a quantity, I'm subtracting everything inside that quantity. So the x plus 2 is going to stay the same, but this is going to become a minus 4x, and when I distribute the negative to the negative 1, it's like taking the opposite of negative 1, it's going to become a positive 1. When I combine my x's, I have a positive x here and a negative 4x here. When I put them together, I'm going to have a negative 3x, and then the 2 and the 1, when I put them together, I'm going to have a 3. With multiplication, again, you're going to need grouping symbols, and I'm going to need some grouping symbols around both quantities now. X plus 2, as well as my function g, which is 4x minus 1. Now, again, I have to use my distributive property, but because I'm multiplying what is called a binomial, if there are two terms, by another binomial, I need to distribute each of the terms in the first set of parentheses to each of the terms in the second set of parentheses. So that basically means that, let's start with this first x. I'm going to distribute the x to the 4x, and remember, anytime you multiply x times itself, it's going to raise the exponent 1. So x times 4x is going to leave me with 4x squared. I've also got to distribute the x to the negative 1. So x times negative 1 is going to give me negative 1x, or simply negative x. Now it's time for me to distribute the 2. So 2 times 4x is going to leave me with a positive 8x, and 2 times negative 1 is going to leave me with a negative 2. You may also have remembered this method as the FOIL method, and that's because the first thing we did was multiply our first terms together. Then we multiplied our outer terms together. Then we multiplied our inner and our last, and that's where the word FOIL comes from. But it's essentially the distributive property. When you're multiplying, you need to make sure that everything in one set of parentheses gets multiplied by everything in the other set of parentheses. Once you distribute, the last step is to just make sure that you combine all your like terms and simplify the expression. So I can't do anything with the x squared. I can't add it to any of the x's because they're different dimensions. But I can combine my two x's. So I'm going to keep the 4x squared, but when I put my x's together, I have a negative x and a positive 8x. This negative x is the same as having a negative 1x. That leaves me with 7x and then a minus 2 on the outside. When it comes to division, again, my f of x is x plus 2, and my g of x is 4x minus 1. And at this point, unless it's a monomial where it's just multiplication and there isn't any addition or subtraction, we're not really going to be able to do much with this. I'll show you later when we get into polynomials how you can factor and then cancel the factors, but at this point, there's really nothing you can do except set it up when you're dividing. All right. The next part of the lesson deals with evaluating functions. You guys have been doing this all along. You're just not quite as familiar with it using function notation. So basically, to evaluate something means to substitute in a value of x into the function and then simplify. So in this example, we know that f of x is equal to 3x minus 2. Well, f of negative 2, all that means is that we're going to be letting x, I didn't mean to cross that out, that we're letting x equal negative 2. Because remember, f of x is the function, and so all I'm doing is I'm replacing the x with a negative 2. So f of negative 2 is simply 3 times, now instead of writing an x, I'm going to replace the x with a negative 2 minus 2. And this is something you can do right on your calculator. 3, sorry, my calculator or my board isn't calibrated, so I'm just going to do this by hand. 3 times negative 2 is going to give me a negative 6. Negative 6 minus 2 is going to give me a negative 8. And so if we have something like this, f of negative 2 equals negative 8, this is going to correspond to the ordered pair negative 2, negative 8. This number is considered my input. It's my domain value. This number is considered the output. It's my range value. It's also going to correspond to y. All right, so you've got several different expressions here that you're asked to evaluate. I'd like you to press pause and take a few minutes to evaluate each of these expressions. So please press pause now. Okay, so you're given a function, g of x this time, and g of x is equal to negative 2x plus 5. So the first thing you're asked to do is to evaluate g of 8. And again, we're just plugging the 8 in for x. So g of 8 is negative 2 times 8 plus 5. And so I know if I follow my order of operations, negative 2 times 8 is negative 16, and negative 16 plus 5 is going to leave me with a negative 11. You can do this on your calculator as well. 3.9. So if I want to evaluate when x is equal to 3.9, again, I'm just going to do negative 2 times 3.9 plus 5. Let's see if I can get this on my calculator. All right, so we got negative 2. And then in parentheses, I'm going to go ahead and put my 3.9. And then we want to add 5. Okay, and we get negative 2.8. Notice that I can also involve other operations. So in letter C, I want to take 2 times g of 5. So I can evaluate g of 5 first if I want, and then multiply it by 2, or I can do the whole thing all at once. It doesn't really matter. Let's go ahead and do the g of 5 first. So g of 5 is just going to be negative 2 times 5 plus 5. That's negative 10 plus 5, which is simply negative 5. And so to evaluate this expression, I'm just going to take 2 times negative 5, and that gives me negative 10. I could have done it all at once, and I can do that down here. So if I wanted to do the whole thing at once, I would simply take 2 times, and then I'm going to write my expression g of 5. I'm going to go ahead and put that in parentheses, and g of 5 is negative 2, and instead of writing an x, I'm going to put my 5 plus 5. And again, you can evaluate that on your calculator if you want. Either way, it's going to give you a value of negative 10. And I'll show you if I put that in. So we'd be taking 2, and then in parentheses, I'd have negative 2. I'll go ahead and put my 5 in parentheses, plus 5, and close it out, and we get negative 10. Okay, same thing with letter D. G of negative 4 plus 2. So I'm just going to take negative 2 times negative 4 plus 5. That is my g of negative 4. And then essentially I'm just adding 2 to the end. Well, negative 2 times 4 is going to give me a positive 8. And 8 plus 5 plus 2. 8 plus 5 is 13. And I add 2 to that. I'm going to get 15. Letter E, now we're looking at g of 2 plus g of 10. You can evaluate them separately if you want. So for example, I can say, well, g of 2 is just going to be negative 2 times 2 plus 5. And that's going to be negative 4 plus 5, which is just 1. And then I can also evaluate g of 10. So you can evaluate them separately if that's easier. And that would be negative 2 times 10 plus 5. And that's going to be negative 20 plus 5, or negative 15. And then if I want to add g of 2 plus g of 10, I'm just going to substitute in the values. I know g of 2 is 1, and I know g of 10 is negative 15. And when I put them together, I get negative 14. Now letter F is a little bit different. Instead of plugging in a number, I'm plugging in an algebraic expression. Don't let that confuse you. You're doing the same thing. I am replacing x with the expression a plus 2. So when I do that, I'm going to have negative 2, and instead of writing an x, let me go ahead and just finish the skeleton. I've got the plus 5. And you should hopefully remember this from when we were using the substitution property in the first unit with solving systems. Instead of writing an x, I'm just going to replace it with an a plus 5. Now this expression I am going to want to simplify. I'm going to first distribute the negative 2. So that's going to give me a negative 2a. That's going to give me a negative 10 plus 5 on the outside. When I combine all my terms, that's going to give me a negative 2a minus 5. So don't let it confuse you if we're plugging in an expression instead of just a number. All right, the last thing I want to go through with you is the composition of functions. When we start getting into inverses, it's going to be important that you understand what this is. Function composition is essentially when you're taking one function and you're evaluating it within another function. So you're taking the independent variable and replacing it with another function. So again, this is the notation that we use. This is more common where you take f of g of x, but you may also see it like this, where that open circle, it's not a cute little way to show multiplication. It means of. And we're basically taking f of g of x. And so if I've got these functions, f of x is 3x and g of x is 2x minus 1, if I want to evaluate f of g of x, what I'm going to do is essentially write the pattern of f, because that's what I'm starting with. That's my outer function. That's going to be the shell. So f is basically 3 times x, or 3 times something. And then I'm going to replace that something with my other function. I'm going to replace g of x with the expression 2x minus 1. And again, we did this at the beginning of the year when we were using the substitution method to solve systems. So the skill itself is something that you've done before. And if I want to evaluate this again, I'm going to need to simplify. by distributing. 3 times 2x is going to give me 6x, and 3 times -1 is going to give me a -3. We can go the other way. So in letter B, this is saying g of f of x, or in other words, g of f of x. So this time I'm starting with my function g. So g, now that I've drawn over it, I can't even see what it says. So g is 2x minus 1. So instead of writing 2x minus 1, I'm going to do 2, and then I'm going to leave space minus 1. Because it's 2 times something minus 1. It's some unknown. And then what I'm going to do is I'm going to replace my unknown with my function f, which is 3x. And when I simplify, I get 6x. This time I don't need to distribute. I'll just have 6x minus 1. And lastly, we have f of x. Big deal. I'm going to take my function f, which is 3 times something, and I'm going to replace the something with f of x again, which is just 3x. And so when I simplify, I get 9x. Okay. So your classwork today and your homework is just to get some practice. There's going to be some practice with solving equations. These are just, to strengthen your algebra skills and get us ready for some of the equations that we're going to be seeing in the next couple of units. So I hope this was helpful. Good luck to you. I will see you next week.